So let's start with company update.
We have a Hong Kong office now. I
Yeah.
signed well, I didn't sign a lease yet. I signed an offer to lease, and I used our company chop, which I learned about. Um, a
What's
company
that?
chop it's an official stamp, and I had to walk to Admiralty to get it. It was in our secretary's office. An official stamp that says Tinycorp HK. So I stamped that on the offer to lease, and now we hopefully have a building.
Great. Mm, Cool. Anything else? Or
That's it.
are sales going? Seems fine.
Yeah, seems okay. I think we sold another one. We're a bit behind on getting orders filled. PNY was slow to ship us the Blackwell GPUs, but I think we got them now.
Great. Okay. Next is the compiler render refactoring stuff.
Yep. Yeah, so I mean the big thing for last week that I worked on was getting float decompositions working, which that's all set up now. So that's FP8s can be emulated into, well, by default the emulated FP16, but it just uses the lattice to figure out which like it goes through each option on the lattice until it figures out what the correct thing to use is based on what you have supported. Same thing with bfloat 16 and FP16. Yeah, those are the only types that are explicitly tested right now. I mean, in theory, it should work for other types as well, but we don't test them, so I
So
guess we should.
I'm a little worried. I mean, these two goals, removing compiler pair and image equal 1, were also your goals on the previous sprint.
Yeah,
This has to, I mean, we need to see progress here,
yeah,
right? Like, I don't know if we need every D-type composition to work, but as far as I know, the compiler pair class is still present in the thing, and not everything's going through the new path. And I don't
yeah,
think we've even gotten to like the challenge yet, which is what are you going to do for OpenCL?
yeah, yeah. No, I have a PR open, which is it's passing all the tests for removing compiler pair. Compiler pair is completely gone. But yeah, that's another thing I should ask about is what to do about OpenCL. So right now, I just replaced the compiler with like the default just like .encode compiler. And so then what you do is you run the same compiler pass. You do it in CL program. Instead, I mean the problem with this is that there's no disk cache, which is why I haven't merged it.
Why is there
But
no disk cache? Why should that
well,
affect the disk cache?
there's no disk cache of the compilation. Um,
What else is cached on the disk?
yeah, the source code is cached.
Where is the source code cached?
Uh, because the compiler is like the capital C compiler is should cache it, right? Or I guess no, because I didn't set a cache key, so I guess it's not right now. It's not, but that could be cached there.
Yeah, so why can't you just use the disk cache but call it from CL compile, the CL program?
Oh yeah, you can. I just haven't done it yet.
Yeah, okay, but so it should call CL compile from CL program, and it should still get the disk cache.
Yeah, yeah. I mean, the problem is that yeah. No, that'll work. Yeah,
And
there's
it definitely shouldn't cache the fake no-op compiler that just doesn't code.
yeah, yeah. No, that
Yeah, that
yeah.
seems
I'll make sure
okay.
that's not being cached. Yeah.
That seems okay, and that seems like an okay way to deal with compilers that need a device.
Yeah. Yeah. So I guess then you keep the compiler class around, and I just turned it into a function. But if you want to have that caching behavior, you might as well just keep the compiler class around. Yeah, that makes sense.
Wait, but you still have the cache for the other ones, right?
Yeah.
How does that work if that's a function?
Oh no, I just made it a function for CL compile.
Oh, yeah, I don't think that's right. I think it should just be the same class, just use
Yeah.
it in a different place.
Yeah, that makes sense.
Cool. Yeah, and make sure all the stuff's tested. I mean, I don't think we have a lot of testing around whether things are properly being cached or not.
Yeah. Yeah. I'll look into this, how we can test that.
Um, yeah, no, again, I get really concerned when I see sprints that have the exact same goal and there's not really like progress toward it, right? Because what you can have is I'm not even sure exactly why we had to decompose floats, right? I understand why we had to do longs, but like you can get this infinite rabbit hole where you're always adding new tasks. And if you're not like popping back off the stack, it's really important
Yeah,
to get these things resolved. And we really need image equals one resolved because a
for
lot of
sure.
stuff is blocked. A lot of stuff is blocked on that.
Yeah. Yeah. No, yeah. Yeah, you're right. Yeah, that ended up being much bigger of a rabbit hole than I realized. That really was, at the end of the day, there's not a good reason to be. I mean, it was not related to the removing compiler prior as much as I realized. Like it was much more about refactoring is D-type supported than anything else.
Yeah,
So
I mean, yeah, we can't have like this is why we have sprint goals. We can't have things just going on the stack like that.
yeah, yeah, for sure.
Can you
Uh,
also comment on the LLVM symbol stuff? That seems to
yeah,
be
so
key.
I tried that. It doesn't happen on my laptop. But I will try and see if I can reproduce it maybe in benchmarks or something. It's weird because I have seen issues like that in the past where something gets loaded. But I ran the one line repo that or repro that was in.
So I think that certainly is not deterministic, right? I don't know
Uh,
if you run the test or run the repro that's from cloud, or I can run something. I can give you like more comment to try later. But
yeah, I tried
if you
both.
just run the test with like minus an auto, like who knows like how many cores you have and things like that.
Mhm. Yeah.
So
I
because
will.
because the arrow seems to be the loading the LLVM symbol and the metal symbol like conflicts or something. I don't know
Yep.
why it seg votes. It shouldn't, but that's what happened, and that's kind of annoying.
Yeah, I mean, for sure, it's annoying. Yeah, I mean, the problem is that I think when you load a library that depends on LLVM, then the dynamic linker doesn't load
So I mean,
the compiler properly.
yeah,
Um,
it's fine if my system load things like in a weird way or like not in like an intended way, but we shouldn't let it crash, right? If we know this is a case, we should at least like patch and like report properly and things
yeah,
like
no,
that.
I believe there's other people who probably have a system that's similar to yours, so this is probably breaking for other people too.
I am not
Uh,
using a special system, so
yeah, exactly. Yeah.
okay.
Um, so yeah, so that's weird. I'll look into that. That's definitely odd. Um, Yeah, I don't know off the top of my head. Also, the thing that Claude said that was interesting was that which I didn't realize this either. What was that metal compiler was never being used with the olds.
Yeah, and that's why if you run the Python-m device on Metal, it always suggests a weird empty compiler. And I think that's just part of the weird thing that was introduced initially for the compiler renderer pair. So there's
Yeah, wait,
that.
actually, I did want to ask about that. There's so that weird like metal. There's two compilers for metal, and um, one of them basically does the CL thing where it compiles in metal program, and one of them
Yeah,
does.
I think that was because there was some issue when you try to use the Metal compiler as other proper compiler, it complains or something. So there was a change that made similar to CL that you just late render your stuff or late compile your stuff.
Yeah.
So I don't want to do that for Metal. I don't really care about CL because no one really uses CL. But for Metal, we have to make sure the fast compiler works. So the fast compiler, the way that the Metal compiler works is that there's a service, and it makes like an XPC call to the service to do the compilation, and we have to make sure that stays working. The main reason we added that was to make Metal work, do the compilation in Beam, so it didn't have to do the compilation in the single process. But we should really delete the slow path, and we should just make 100% sure that the fast path works.
Yeah. Well, the
I
interesting
think
thing that
now there's like the real test benchmark. We should use that like reasonably to catch things like these.
yeah. Yeah. Well, anyway, the thing that Claude had been pointing out was that it wasn't like before this change. It wasn't using the fast path. That's the fast compiler.
Yeah, I totally believe it. It's probably something we didn't test that well.
Yeah. So I mean, just keep this in mind when you do the cleanup.
But yeah, what I would like to do is just delete the slow path entirely, and make sure that the fast path works.
Yeah. The thing I was wondering is like maybe like there's like a version of macOS or something like that like doesn't have like this API or maybe that was the reason it was added. But I guess if it's just like
No,
oh,
I mean it started with the slow path, I think. Then the fast path was a service that was added after,
I
and
see.
the old one was not deleted. I believe that's the case. Just use Cloud to relook at history and
Okay.
medics.
Yeah. Yeah. No, I looked really get playing a little bit. But yeah, I just want, especially considering that like this thing is segfaulting on your laptop, but it's not segfaulting on my laptop. I want to make sure that like my laptop isn't weird and like.
Yeah, that's fair.
Yeah.
I mean, those tests run in separation or single core doesn't sometimes seems fine. So they're certainly not that deterministic. It's just
Yeah.
sometimes
Anyway,
the
I'll keep that
changes
in mind for this change.
Okay. Sounds good. Okay. Next we have Llama training. Flash attention.
Yep, I think we're up 2x on MFU over last week, so we're at about 8%. Coslin's branch supposedly gets 9, but I haven't been able to reproduce that on AMD3. Not entirely sure why. Look into it. Eval is still pretty slow. I don't think it's hitting the fast flash attention path. And then I know Coslin has also been looking into faster flash attention kernels. And I think I want to try getting the hip kittens one working and seeing if that's faster.
So I know the proper hip kittens one. I know their gem doesn't actually work. They didn't test it very well. There's race conditions in it.
Supposedly, their flash attention one has a Llama training example.
Yeah, I'll believe if they actually trained any Llama. I mean, the one I'm more interested in is the one that was actually used in MLPerf.
Yeah, I think that's the ITER one. And I can look into that too.
Yeah, I wonder if we can grab that.
How do I update
Um,
the 4.2% MFU to 8%?
Yeah, we'll do that.
Oh yeah, the gem.
Yeah, I was thinking about this yesterday. So our latest run is 22 hours.
Yeah, 22 hours.
So that's about 10x diff from the MLPerf. And we know they supposed to trend with FP8, something like that. So that's probably 2x.
They
So we are
definitely
still,
trained with.
so we are
So
still 5x.
Yes. I think
They
their step
definitely.
is 500 milliseconds for BS16 step.
Wait, our step's only like 2 seconds.
For a BS8 step. So we need about 2x their steps to complete.
Oh, I see. We're not running BS16 because we can't fit in memory.
Yeah,
But if we can fix the memory, we can run via 16.
Yes.
I think that'll get us a good bit of MFU.
Why
Yeah.
would that be slower, low? Is flash attention
Just-
faster if you have bigger tensor? Something like that?
No, it's not about that. It's about RAM.
Oh, so we are waste some RAM is what you are saying.
Well, if you do grad accumulation, the flops are the same, but the RAM bandwidth doubles.
Yeah, but is that a bottleneck? I saw it's bottleneck by flops.
Gem might be bottlenecked by flops, but everything else is probably bottlenecked by RAM bandwidth.
Interesting. Okay.
Or at least like
Okay.
our ability to access the RAM anyway.
Mhm.
But yeah, we gotta improve that profiler script a bit. Make sure to exclude eval. I don't know why it says custom forward is slower, but yeah, I think looking at other flash engine kernels and
So it's that, and then I'm still seeing this weird issue where every like 300 or so steps, there's one step that takes extremely long. I posted about this before in AMD hardware.
yeah, it seems like one of those like 4 billion overflow kind of things.
Yeah, and the weird thing is the amount of time this extremely long step takes increases over time. So near the end of training, the step is taking like 5 minutes to complete, which seems very wrong.
Yeah, this definitely sounds like some driver thing. Nimble, any ideas?
Actually, no. I'll take a look. I think so. From my profile, it just stuck in the submit function. But yeah, I'll take a look. Maybe it's something about ring buffers. I don't know.
Not sure is what it sounds like, especially if it's like deterministically a number of steps. Some ring buffer overflow thing. In general, the way I like to debug like ring buffer edge conditions is to add an environment variable that make ring buffers very tiny and then see what happens. Like, I think the way to like debug this kind of thing is first to try to get it to happen more often with whatever it might be.
Yeah.
Oh, cool. Yeah. Overall, I'm pretty happy with progress. If we can get, if we can continue to get these kind of MFU improvements week over week, hopefully, yeah, hopefully we get it up to like 20% this week, and then next week we can start thinking about actual 4.5B.
Yep. And there's some other stuff to hit before 405. Like, I'm not entirely sure if model parallel works currently.
Oh yeah, we should try that with 8.
Yeah, there's some stuff to test before then.
Cool. Yeah, hopefully I don't think the refactor broke anything. I tested it. We no longer have custom kernel. Custom kernel is now call. And hopefully that syntax makes sense. You can just basically call a kernel. You can put a kernel in, be that a kernel with a sync, like Tiny Kittens does, or a kernel with a kernel UOP, like the ASM gem does. So.
Anything else for Llama training?
That's all.
Okay. Next we have drivers.
Yeah, so this week I've been fixing different issues. So yeah, in AM backend, QCOM also was fixed. Also, we now have, like, for the EMD GPU driver, we should have like fast exit, so not waiting for the whole timeout. I'm still experimenting with recover with the AMD GPU, but I'm not sure. I'll test better heap. I'm not sure if they can recover from page faults. Like, it looks like it just marks the PEAT by default and kills it.
I can definitely do a lot of stuff on my system, which brings down the entire system. So I'm using the AMD, GPU kernel driver. But yeah, it's really annoying on my laptop when it brings down the whole display, and then I gotta reboot. I wonder if there's anything we can do.
Yeah.
I mean, I don't know. HIP might not be any better about this.
Yeah, I'll take a look, but currently I've just made heap running on the tests, like the GPU crash ones, and it just, after the first failure, it just for other calls it just returns an error. So it's like a bad state in heap either. I don't know, maybe our backend doesn't support something. Yeah, I'll take a look into that.
I mean, a
But
bad
for
state
memory
in
files, yeah.
a bad state in HIP is fine if we can't save the process, but does it crash the like display on the GPUs? It's one of the things I want to test with the new Strix Halo computers.
I mean, probably it crashes when it just resets the GPU or something like that.
What I've noticed is that my computer will stay up as long as the Python process keeps running, but as soon as I kill the Python process, it then brings the computer down.
Yeah, I see. I know,
So
if
yeah, I
you
wonder.
can grab dmask and share these. I know, maybe
Well,
something in logs what AMD GPU tries to do.
yeah, I mean, we should be able to reproduce this now on the Strix Halo machines.
Actually, yeah, I can try to do that, but I've never seen it crashing, like rebooting the whole system.
It doesn't reboot the whole system. It just brings down the display driver in a way that it doesn't recover. So it brings down my monitor, and it's a laptop, so I don't really have a choice but to reboot. But fun fact, Metal. If you run a long-running Metal kernel and kill the process, not only does the kernel not die, it seems to run forever, and then your laptop appears normal and usable. Your Mac, except that when you run Anytop, it draws 40 watts. And I asked
Yeah,
the MLX guy about this, and he's like, "Oh, you just have to reboot." I'm like, "Wow."
yeah, I've experienced exactly the same. Yeah,
It's crazy. It's crazy that Apple doesn't have like real process isolation on their GPU. Yeah, and that the MLX guy is like, nope, we don't have any way to reset the GPU. So yeah, if we get this working, we're doing better than Apple.
yeah.
Any progress on NVIDIA profiling? Is that the driver?
No, no major progress. So yeah, this week I'll dig into the issue with Llama and focus on the NV.
I see Harold on this call. Do you have any issues that you want to bring up here?
No, we just merged Tinygrad calibration and removed OpenCL from OpenPilot, and so far that seems good. So making some progress.
Nice. And yeah, if you want us to make sure the speed doesn't regress on that, just make sure we have it in our benchmark.
Yeah, I'll add a
with
PR
a-
to put it in CI.
Cool. Yeah, I mean, if you assert a min speed, then it can be our responsibility to make sure that stays reasonably fast.
Sounds good.
I think you guys are gonna like the new export functionality when it comes to. It's gonna be really easy to just save graphs and not have to deal with like the JIT stuff.
Oh, it's not gonna be a pickle anymore?
It's still a pickle, but it's a pickled
I see.
UOP graph instead of a pickled captured JIT.
I see.
And
Yeah, that
it
sounds a bit
doesn't
nicer. Oh, I
mean-
have one question actually. When we move to Rangeify, the compile speeds slow down a lot, maybe like 5x or something. I mean, we can work around that, but is that something that's gonna be improved ever? I don't really know why it happened, but like, is compile speed something you guys care about?
we care to the extent that people who use Tinygrad cares. So if you have a benchmark or something and you say you want that to be something, then we will look into. I mean, we know why it becomes slower, but
I see, but it's not. There's
Yeah.
no fix on the roadmap until it becomes a user's priority.
Yeah, so I'm gonna do some fixes for Llama, hopefully this week, but these fixes won't apply to Comma's model. They're just fixes because Llama has a layer-based repetitive structure.
Oh, I see. Yeah, okay.
so
If it's a problem, I'll make an issue and say what speed we would like.
yeah,
Sounds
because
good, yeah.
these are generally like we are pretty tolerant on this front. Maybe we shouldn't, but we kind of know why it's slow, and specifically for Rangerify, we make a trade-off saying, okay, this needs to be done. So if there's speed regression, we will fix it later. Who knows what later will be?
Wait till we merge eGraphs, it'll all get 2 times slower, but better.
Oh no.
Great, sounds good.
I mean, slow compiles and fast runtime is a good trade-off, I guess.
It's not really that. It's supposedly to make the code simpler.
Oh, I see.
No, so I think it would be the good idea if you just open an issue or something saying that you see the 5x. I mean, you say you measure that, and I believe you, but it would be nice to have this somewhere. And when we come to like how fast this should be, well, we will use that as an example to target.
Okay, I can open issue with that.
Yeah, if you say what it used to be, I mean, yeah, we know that Rangerify regress things here.
Sounds good.
Well, thank you for being a happy Tinygrad user.
Yeah, no, the Tinygrad is much more beautiful than OpenCL code, so.
Great. Okay. Next is my stuff. Also, I did some DevOps last week. I went through all the past 2 months of flaky CI tests and root cause slows. So I saw there's another one that's new, that's like numerical thing on one of the new tests, but I think now it should be much better. All the assigned numerical tests use int. All the things that only crash on CI, I skip it. Something that's broken I fixed. So I hope it's much better now. There are a few assigned tests that I really don't know why it only crashed on CI. One hypothesis is there's one unit test that loads 2 gigs of memory, and our tests use about 8 gig of peak memory. So if you got unlucky distribution, maybe something would be bad. That's my guess.
What test uses 8 gigs of memory?
Like 8 gigs of peak memory if you load things in a very bad order. Because there are a few tests that use gigs of memory.
Yeah, we should figure out what's using all that RAM. So there's actually a limit. I have like a limit of like the buffer
So there's a
size
limit
in
for
CI.
single buffer, but for
Yeah.
example, our GUF test loads a model, and it loads a model in Tinygrad. It also loads a model in GGML. Then it compares the output.
Hmm.
So there's like 4x of your model in the RAM or something like that.
Sure.
Yeah, so I don't know. I don't know if that's real. So, I don't know. Yeah. Hopefully that's better. And assign set item. Continue make progress on that. I remove some rules and paths and hacks in various places in schedule and Rangify. And now I can move stuff from tensor.py, those contiguous and realize gradually into Rangify that solves this. So
Yeah, I saw
eventually,
that.
yeah.
What did
Even,
I saw you changed 3-item assign to something else?
yes, I changed it to just make it an arc after you extract the shape steps.
The movement ops become an arc.
Yes.
Yeah, it's probably cleaner.
I think it's much better. Like you don't need to allow this in spec and have like later have a hack somewhere saying because for the assign the shape is the source of your assign, right? So previously it was reading something else.
Yeah, I don't fully understand that hack. It's nice to see them getting cleaned up.
Yeah. So now I think once I finish the set item cleanup, it will mostly boils down to the realize in assign. So we currently still allow some special bitcast assign for disk because disk is special and there's I don't know, some legitimate use case for that, I assume, after or something. So still some special paths for disk that I want to understand better. There's also this TinyFS regression I apparently made and I reverted later. It's nice that we have a way to test it in benchmark, but I still don't quite understand if that was a hack or proper workaround or something. That I
Do
need
we
to understand.
need Can we test it in non-benchmark? Can we test it in CI?
Can we test that in CI?
At least we can test through the schedule stuff in CI. So that's actually what caught it, is the CI test caught it.
Now we partially test it, we just don't test the execution.
Yeah, we don't test the runtime in CI. We test the runtime in benchmarks.
Why can't we test the runtime in CI? Why can't we like stand up a little TinyFS server?
I guess we could. I don't know. There's a couple parts to standing up a TinyFS server.
If I
Probably good
break
to
it
have
later, then we discuss how to do. I think now scheduling is probably fine.
Yeah.
You're good with it.
Yeah, the other is the scope of but for now we have some logic saying if something is realized, then realize it again won't change the output, but that's not true if you do a like slice assign to it. So there's some scope capture there. I have like a 100-line complicated way to do that. I don't really like it, so I would think about that more. But I have something that removes all the realize in tensor.py and all the task paths. It's just not very beautiful. So that's the
I'm
eventual goal. Eventual
I'm
goal
very
is
excited for that
the
realize to be
disk.
removed.
Yeah. So the eventual goal is, I think I said this maybe a week before or 2 weeks before, but disk should just use regular assign paths so it can be lazy. Then we don't do any realize when we do schedule or just put assign. So that's the goal.
If disk assign is the same thing, then that works. I've always thought that disk assign might actually be kind of different.
There's no fundamental reason that should be different other than disk cannot do ALU. So anything you want to construct your source, you need to do that in other device.
Yeah, but disk also has this property where like your ordering of like if you do 2 slice assigns,
Mhm.
there's a real backing store. I guess I don't. I should read what you've done with the semantics of assign. Like, do we have like a fixed set of understanding of what the semantics of assign should be?
Yeah, that we do.
Cool. And if you think it's the same as disk, then yeah, I just gotta read this, and because we were
And
never
then
totally clear about like what slice assign even really means.
slice assign for now just means, so it's like in get item we have a view of a tensor versus like advanced get item that returns a new tensor. So
If
for
I slice assign in a JIT, does it apply?
I think it should, but currently we are not capturing that correctly.
Got it.
So basically, the output should be, my ground truth of output is it should give you the same output as eager output. Imagine you just add realize to every line.
Yeah.
The problem for JIT is the slice assign case. If you don't have explicit realize, we are not capturing that because it's not like in the output. That's pretty much the reason why we need to add realize everywhere in the front end.
Yeah, I mean, I think we can just kind of have a JIT thing that tracks all the assigned tensors as well.
Oh yeah, so there are I have two main solutions on this. One is build a dependency global-ish map like all tensors to track this dependency. I really don't like that. Another is to use some after structures to wrap everything. That is better, but that's more complicated when you need to resolve this after dependency.
I see. Let me know if you
Yeah,
want me to look over any spec and
Yeah, so I think my priority would be if I can have a relatively clean way to do this with a global map that's like handled properly, I will probably merge that. But I also want to explore just like try to make this structure into the after and its U up, then let the backend figure it out. I think that's better. Yeah,
Cool.
but I think now we have pretty much all the cases. I also compare this with the test case for Torch and Jax and NumPy to make sure like everything, like it won't be a surprise basically.
right?
Yeah, well that's the goal. Yeah. And that's my stuff. Next is assembly, I guess also the code refactor.
Yeah, so I spent most of the last week on the call stuff. I'm very happy with where it ended up. We removed 2 ops, so kernel and custom kernel no longer exist. And call is universal. You can put 3 things on the call. You can either put something that's at the tensor level, and that will basically just kind of lambda function into the tensor graph. So this is useful if you want, like, this is what I do with embedding. So if you want to like have the normal embedding forward, have a tensor graph, and replace the call early, you can do that, but you can still have a custom grad function on that. Call can also be used to define a custom program in UOps, and that'll run the normal UOP compiler flow on that, but it's already lowered down to the like the load store layer. The ranges are done for you, all that stuff. So that's like what Tiny Kittens is. And then the third thing is you can just have a completely custom program, and it just uses the program UOP. And I think that this call thing, I added hooved because it's finally the correct thing to do exports as renderers. So we could like export to web GPU just entirely as a renderer. And I was thinking, I've been starting to think about how this could kind of even replace the JIT. I'm like, we're finally there. I have to do a little more cleanup, so I want to clean up schedule cache. Right now, schedule cache has a hack called LUnique, which puts LUniques on the buffers for local unique. This is nonsense. It should just be param. So then the entire schedule just becomes, all the inputs become param, and then everything is the same at every level of the hierarchy. I also need to add some tests to do calls at multiple levels. So like it doesn't just, this can be a completely multi-level hierarchy. It doesn't just have to be a 2-level hierarchy where you have like any concept anymore of like a schedule and then a kernel. It's just this thing with calls. that can nest multiple layers deep, and the other thing should be able to handle that. So yeah, I mean, my goals for this week are to use param and schedule cache, clean up the make sure the multi-level call is correct, and then clean up and remove schedule item, because we don't need schedule item anymore. That's just a UOP graph. Yeah, so I'm happy with how things are progressing here. I spent this morning playing with egraphs and playing with Mirage. Mirage is kind of the state of the art of mega kernel stuff now. I'm just looking at what they're doing and what we're still missing, and what the new kind of optimization stuff is going to look like. But yeah, a whole bunch more call cleanups. On the assembly side of things, I mean, at some point we just have to kind of decide extra AMD is good enough. I posted about it, nobody replied. If anyone thinks the code is like not good enough, I don't know if I'm in my agent psychosis era where I think it's good enough and it's actually awful. But I don't know.
It's, if you're happy with it, sure. I don't know. Are you happy with it?
I can certainly do more to clean it up,
No,
but
it's not about if you can or cannot. Are you happy with that? If
I'm
someone
happy with
else make that PR and say merge this, will you click merge or not?
probably not. And we can yeah, well, probably not without talking about it a bit more. What I am happy with that PR is the API. Like, I think the actual API and the DSL are very good.
Mhm.
And you know, that was all the part that was done by hand.
Yeah.
The actual like, particularly in files like asm.py, like yeah, like it's AI slop, but it's just like it's a function. There's no other way to like implement it. There's just like a lot of crap there. Yeah, I could probably clean it up. I could probably knock 100 lines off it, but I don't think I could make it any conceptually cleaner. So I think if someone else put that PR up, I would struggle for a while and be like, you can make this cleaner, you can make this cleaner, you can make this cleaner. And then I spent, 2 weeks struggling to make it cleaner, and it's like, yeah, sure, I can make the code nicer, but I can't make the API nicer. So,
Yeah, then I think that's
um,
fine.
yeah, I mean, I kind of think we just move it over, and look, TinyGrad is a living code base. It's not like set in stone. But what I am happy with about it is I feel that finally the decisions were made correctly about like how the DSL works, how the emulator works, and then like the SQTT and the disasm stuff. They're kind of crap, but like who cares? Like, okay, we can clean them up later. We don't like have to keep it an extra. So yeah, I think that kind of merges. I gave T I gave T Thompson feedback on x86 assembly. I mean, he could. I struggled with the same stuff with the linearizer with him. I like the linearizer so much that I ended up doing the stuff myself to get it merged. I don't love this x86 assembly stuff this much. If he's excited about getting it merged, then he'll take my feedback. If he's not excited about getting it merged, then he won't.
Okay.
But yeah, no, I do think there's some good stuff there. It's pretty fast too. The x86 backend is pretty good. It's faster than without Beam. It's faster without Beam than playing. So yeah, and I think it does a bunch of things right, but I think that we still have to deal with that ops thing, and I think the answer is something like ops ins, not massively polluting the ops space with like all the x86 instructions. And that'll also work with the RDNA 3.1 as well. So yeah, okay, cool. I'll get extra. I'll just merge that stuff from extra assembly. It's 4,000 lines. It's nice to not have to use Python path. It can ship with the thing. It can ship with TinyGrad proper. And yeah, I mean, it's a full, if you think about how many lines AMD used to write basically that same thing, probably 100,000. More than that.
Yeah, I think those are fine. It's not as
Yeah.
annoying as like some random functions in scheduler.
No, it's not. It's not, and it is well isolated. And that's
Yeah.
not entirely an excuse, but it's the most important thing is complexity management, and the things in there that aren't perfect will not creep into complexity elsewhere in the code base.
Yeah, so I mean that's pretty much why it's fine to merge that. I think very similar reasons for a lot of like 1,000 lines of inclusion.
1,000 lines of which?
It's like when we add annex or something like that.
Yeah.
It's its own thing, so it's fine.
Exactly.
Okay, sounds good.
Oh, it has a bunch of tests too. How do you feel about moving? So right now we have a lot of test files in test/startup.py. How do you feel about moving those to something like test/ like backend specific or something like that?
I mean, I don't have a strong preference as long as easy to discover the test.
And it'll be another subfolder, so it won't be like test/test ops anymore. It'll be like, test/E/test ops. Or test/integration/test ops.
I don't have strong opinion on this.
Yeah, I mean, my only reason to do it is just so we can stop like using like --ignore, because like right now we have all these like
Ignore too much.
--ignore models.
Yeah, I think just pick one. Maybe just have your cloud suggest something or see what other repos structure they will test. It'll be fine.
Yeah, I'll do some research into this. But yeah, the reason I want to do this is so I can put the AMD assembly tests in like test assembly or something.
Sure, sounds good. Okay. So Causeway's not here. I think she put the updates in Llama channel for things. Then what else do we have? B1TG, you want to share something about FP8?
Oh.
Hello.
I was trying to add the FP8 hybrid mode, which the ML perf train using. So I think this may be helpful for the ML perf submit.
By hybrid mode, you mean using bfloat32 flash attention and FPHM?
Hybrid mode means in the backward there are two metamail. The grade quantization method use E2 M5 and the forward metamail use E4 M3.
Also use one FPA for forward and the other one for backward. I think NVIDIA like suggests this 2 years ago.
Yeah, the AMD ML perf their Llama train using this config.
I see.
And yeah, we should be able to support it the same way we do the normal. Like, I don't know if we have a flag explicitly for accumulate in, but you just need to put the caster on the expand.
The issue is
the issue is that for now, our backward D type is always the same as the forward D type.
It shouldn't have to be. So if you put the casts around the expand?
So if your forward always run with the, say, the Mantissa 2 version, then how can it know that in backward it should use the Mantissa 3 version of FP8?
Yeah, you have to put the cast and cast back around the expand, right? So if you think about what a map mul is an expand, a mul, and a reduce.
Mhm.
So in the forward pass, whatever data type that reduce has is going to be your reduction data type. But in the backwards pass, it's the expands that become reduces. So if you put a cast before the expand to what you want the backwards D type to be, and then a cast after the expand to put it back, then when you go backwards through that, the expand becomes the reduce and it'll have the correct D type.
Yeah, but wouldn't that means in your forward you actually do the cast?
Well, yeah, but they should cancel out.
Cancel out with what?
Each other?
So we certainly don't do that automatically now.
I know, and we might want to.
Okay. That,
I just use custom kernel to do this.
Yeah. It's fine, I guess, but no, I mean, I think we should make this work, and we should add a like a backwards D-type flag to gem. This is the problem with custom kernel. Now that it's there, everyone's going to use it.
okay. I think would be nice to support this in cluster kernel to start with. This is similar to flash attention. Then once we understand how it works, we can think about how to upstring it to Tinycorp proper.
Yeah, it's fine. It's fine to use custom kernel, especially if we're using custom ASM gems.
And I also need to reflect the console code to support different D-type in. Currently, the A and B at the same time. But the mixed FP8 MetaMail have different FP8 type. So you can read the PR later.
Sounds good. Hey, what else? Oh, what's up with the CPU Llama 1B speed something torch something? Is that still a thing?
I mean, people are working on it. If they actually succeeded, I'll give them that bounty. If they succeeded, it was something that can be upstreamed.
Because none of the attempt try beam, so I don't even know if I just run beam today. Is it faster? Is it not faster?
That's crazy that they're not using beam. I mean, I
Because
don't know.
I imagine the bounty is just find a way to run this model faster than torch. So before upstream any change to the behavior, we should benchmark with beam. That's my thinking. And not mess around with the heuristic.
My understanding is, yeah, I mean, this one that I see is making a custom matvec kernel. I don't think Beam gets it. I think I tried it with Beam.
Yeah, but my point is, even with that, it's weird that it's not using beam to compare. But I don't know.
Oh, but if they write a custom kernel, they're not going to use Beam.
Yeah, but there are other parts of the thing. Anyway.
I bet you it's all the matvec.
Okay. Oh, I have a change that correct the bandwidth for MOE for LLM.py. but I don't. I see a good number from growth. But that number
Yeah,
looks. The GBS number looks weird, even if you accounted for the 5x for active experts. So I don't know what's happening there.
I bet that the GBS number fakes accessing all the experts.
No,
right?
no,
Because
but even that, you divided that by 6. I think that's the number for 4.7 flash. It's still pretty high.
I mean, if you're getting 20 tokens per second, that seems good. Double that and it gets a bounty.
Yep.
Yeah, I'm pretty happy with the progress on that. If we can actually beat Llama CPP for that, people might use it.
Mm-hmm. Do we have anything in bounty? Nope. Do we have anything in issue? I'm sorry. Okay. I think that's it for this meeting. Thank you, everyone. See you next week. Bye-bye.
Bye.